Hello, algebra students. Welcome to lesson 9.2 on solving quadratic equations by factoring, right? So this is our topic 7, end of topic discussion on factoring and how we can use that to solve these quadratics. So say bye to Desmos for a little while, right? Graphing was fun, but now it's time to get down to paper and pencil mathematics. All right, so example 1 says, how can you find the solution of the equation x minus 9 times x plus 2 equals 0? So there's this thing called the zero product property. Basically, you learned it, I don't know, when you did your times tables. Basically, it says anything times 0 is 0. That's what it says, right? So what it's saying is, if you have two things being multiplied together, A times B, right, this right here, and the product is 0, one of them has to be 0. Either A is 0 or B is 0. So if I bring this down here, I'll use purple, how about that? Right? There are two situations for this. So for these two factors to multiply and get 0, either x minus 9 has to be 0, and then 5x plus 2 would be what it is, or the x minus 9 is what it is, and 5x plus 2 is 0. So don't copy that down, put a 0 in its place. One of these situations must be true. So what we do here, because in the first one we replaced x minus 9 with 0, we set x minus 9 equal to 0, and we solved this by adding 9. And x equals 9. So if we were to plug in, and let me move this over here real fast. So we get a value of x equals 9. So if we were to take x equals 9 and plug it into our original problem, right? 9 minus 9 times 5 times 9 plus 2 equals 0. I don't care what this comes out to be, whatever. It's not 45 plus, that's 47, right? Who cares? But this comes out to be 0. And 0 times 47 is 0. So that would be good. The other one here, right? This case, we let 5x plus 2 equal 0. So we set 5x plus 2 equal to 0. Now this takes two steps. We subtract 2 from both sides. So 5x equals negative 2. We divide by 5 on both sides. So x equals negative 2 fifths. That's a decimal, negative 0.4. You could also have that, negative 0.4. And now if we take that and plug it in, so we would have negative 2 fifths minus 9, not plus 9, minus 9. That's the first. And then we would take 5 times negative 2 fifths plus 2. Well, negative 2 fifths minus 9 is some negative number. I don't know. I don't care, right? But when you take 5 times negative 2 fifths, this becomes negative 10 fifths. And negative 10 fifths becomes negative 2. And negative 2 plus 2 becomes 0. And any negative number, any number times 0 is 0. So that's why this works, right? Okay, so this zero product property, very, very, very important. But first thing is, you gotta be set equal to 0, right? It's called the zero product property because it equals 0. So don't forget that. And then once you have that, factor it, and then set each factor equal to 0. All right, cool. All right, so let's get right into all this fun stuff. Okay, so example 2. How can you use factoring to solve x squared plus 9x equals negative 20? So again, the standard form for a quadratic equation is ax squared plus bx plus c equals 0. You need to make sure that that right side is 0. So let's take our original equation, x squared plus 9x equals negative 20, and make one side equal 0. Well, you only have to move the minus 20 to the left by adding it, so let's do that. Let's add 20. This 20 will not combine with the x squared because it's not a like term. It will not combine with the 9x because it's not a like term. It'll just be the c value, the third term in your quadratic, x squared plus 9x plus 20. And now this equals 0. And check, we're in business. So now it's time to do our factoring of x squared plus 9x plus 20. First thing is, I look for a common factor, greatest common factor. No coefficient, no x's, none. There's no GCF. So now we get our x over here, right? Our c value goes up top. That's a positive 20. That means our signs are the same. Our b value is a positive 9. That means plus and plus. Same signs, positive signs. And now, I'm looking for the factors of positive 20 that sum to positive 9. And again, by now we got to be quick, right? I'm going to be very, very quick. 4 and 5 make 20, right? So 4 times 5 make 20. Keep them both positive. Positive 4 plus positive 5 is positive 9. Good. So our two numbers are positive 4 and positive 5. It doesn't matter which one goes where. Positive 4, positive 5. So this now becomes x plus 4, x plus 5 equals 0. And now, for these two factors to multiply to get 0, one of them must be 0. So either, I'm going to come over here, either x plus 4 is 0 or x plus 5 is 0. And we solve. Subtract 4, x equals negative 4. There's one of your solutions. Subtract 5, x equals negative 5. There's another one of your solutions. And we're done. And that's the answer to this question. All right, great. Next. Okay, example 3, it says use factoring to solve a real-world problem. A museum vault has an outer steel wall with a uniform width. The area of the museum vault ceiling and the outer steel wall is 1664 feet squared. What is the width of the outer steel wall? So the area of the museum vault ceiling and the outer. So again, this is a vault, right, looking down. They're telling you that the area of this space, right, including the thick steel wall, the area, right, not the volume, the area is going to be this, right? The area is this. So this is just area of a rectangle problem. Okay, so don't overcomplicate. Area of a rectangle is base times height. Now, we do need to figure out the expressions for the total area because they're adding x on every side. Every side gets x. We've done this. I feel like I'm blue in the face. We've done this so much. So this dimension right here was originally 20. But now we're adding x here, and we're adding x here. We're adding 2 x's. There's the dimensions of that side. This side was originally 40, but again, we're adding x here, and we're adding x here, so now that's plus 2x. And there's those dimensions. So our base and height is 40 plus 2x and 20 plus 2x. We're going to multiply those two together. So I'm going to do 20 plus 2x times 40 plus 2x. And that's going to equal our area of 1664. Now again, these numbers are big. I'm sorry. It is what it is. So we're going to multiply this left side out. I'm going to use the box method, right? So 20 positive 2x, 40 positive 2x. 20 times 40 is 800. 40 times 2x is positive 80x. 20 times 2x is positive 40x. And 2x times 2x is positive 4x squared. So now if I put this in standard form, put the 4x squared first. And then combine your 40 and 80x to get 120x. And then your 800 comes last. And that equals 1664. And now, if I want to try to solve this using factoring, I need to bring the 1664 over to the left by subtracting it. It will combine with this 800 because they're both just numbers. So we get 4x squared plus 120x. 800 minus 1664 is negative 864. And that equals 0. And we have the coveted 0. Great. So now we look to factor. First thing is GCF. 4 will go into 120. 4 will go into 864. So 4 is in my GCF. Now because 864 does not have an x, there's no x in my GCF. And now what we're going to do here with this GCF, right, this 4, is we're going to divide everything by 4. In the past, we would have pulled that 4 out, and we still can. But because this is an equation, and as long as you do the same thing on the left and right side, we can go ahead and divide by that 4. When we do this, I'm going to bring it over here. You get x squared plus 30x. So I'm dividing everything by 4. Plus 30x minus 216 equals, and 0 divided by 4 is still 0. And now look at that. We went from 800 to 200. Okay, these are still big numbers, but let's try to handle it. Okay, so now I'm going to draw my x. I have a negative 216. That means my signs are different. So one's plus, one's minus, and I want a positive 30. So now we're looking for the factors of negative 216 that sum to positive 30. And when I say sum, I really mean subtract to positive 30. Okay. Now again, I'm not going to start with 1. I'm not going to start with 2. I'm going to try to go a little bit closer. So I'm going to start with 4. Right? So if you take 216 divided by 4, you get 54. So 2 and 54 make 216. Right? Now, if I want a positive 30 in the middle, but the signs are different, then I need to make the bigger number, right? I didn't mention that. The bigger number must be positive. So here, we're going to do negative 4 plus 54. That's positive 50. That's not positive 30, so it's not that set. 5 does not go into 216. Let's try 6. So 6 times 36 is 216. Again, just do that by division. Make the bigger number positive, so negative 6 plus 36. And yes, that does give you positive 30. So your two numbers are negative 6 and positive 30. Negative 6 and positive 36. And positive 36. So my two factors are x plus 36 and x minus 6. Now, in order for those two factors to multiply to equal 0, one of them must be 0. So either x plus 36 is 0 or x minus 6 is 0. Subtract 36 from both sides, so x would be negative 36. My equal signs, I'm putting negative signs for some reason today. And then over here, I would add 6 to both sides, so x equals positive 6. So here are my two answers. But we have to think of this as a word problem, right? The x is the width of the steel wall. Can your width be negative 36? No, it can't be negative, right? So in geometry, there are no negative lengths. If you watch the, what's it called, Stranger Things, right, on Netflix, maybe it's the upside down. In the upside down, there might be some negative lengths, but not here. So our x value is 6. So your width of this steel wall is 6 feet. Right? So again, some pretty cool applications. Now, when you do applications, maybe it's better to graph the function once you get it so that you can easily grab the answer. But again, never a bad thing to challenge your mind. Okay, this was video 1. Video 2 is coming right up.